Welcome to Sir RP's channel. In this video, you're going to learn how to solve joint variations. Are you ready to learn? Sit back, relax, and get ready to learn. We're now the third type of variation, which is joint variation. It is a type of variation that involves direct relationship of more than two quantities, almost similar to direct variation, but differ in the number of quantities involved. That is, if any of the independent variables increase or decrease, the dependent variable also increases or decreases respectively. For example, the area of a triangle varies jointly as the base and height, since the area will increase or decrease if the value of any of the base or height increase or decrease respectively. If z varies jointly as x and y, then z is equal to kxy, where k is the constant of variation. This is what we call the equation of joint variation. It is a mathematical sentence that describes the relationship between two quantities that are jointly proportional. Y varies jointly as x and z. It's written as y is equal to kxz, where k is the constant of variation. Take note of the order. We have y varies jointly as x and z. So that is y is equal to kxz. For example, if y varies jointly as x and z and y is equal to 28 when x is equal to 2 and z is equal to 7, what is the equation of variation? In this example, you're asked to give the equation of variation. To find the equation of variation, transform the variation statement into a mathematical sentence. That's the first step. Substitute the values of y, x, and z to solve for k, and write the equation by substituting k to the original equation. That is y equals kxz. This is our mathematical sentence. Then substitute the values 28 for y, 2 for x, and then 7 for z. Multiply 2 and 7, that is 14. Then to find k, you divide both sides by 14. 28 divided by 14 is 2. Your value of k is 2, that is the constant of variation. And from there, you're going to substitute k to the original equation for you to find the equation of variation. From there, you're going to substitute 2 to k, making y equals 2xz as your equation of variation. That is how you solve or find the equation of variation. Let's try translating or transforming variation statement into a mathematical sentence. Write the equation for the statement m varies jointly as n and o. It's very easy. Just look into the values and remember the equation or the form. You have m is equal to k and o. Do not forget k because it's the constant of variation. That's it for translating. Next, if z varies jointly as x and y, and z is 48 when x is equal to 4 and y equals 15, what is the equation of variation? This is similar to the example presented earlier. You are going to transform first the mathematical statement, and then you're going to find the value of k, then write the equation of variation. First, translate the variation statement to an equation. Z varies jointly as x and y, so that is z is equal to kxy. Then solve for k using the values of z, x, and y. Z is 48, x is 4, y is 15. You're going to multiply 4 and 15, that is 60k. Then divide both sides by 60. You have 48 over 60, then transform or reduce that to its lowest term, that is 4 over 5 or 4/5. Then from there, you're going to substitute the value of k to the original equation to find the equation of variation. So we are having this value 4 over 5 because that's the value of k. And then using the original equation, you will have z is equal to 4/5 xy as your equation of variation. That's how we solve for the equation of variation. Next, The variable z varies jointly with the product of x and y. Find the variation constant in the equation of variation that relates the variables if z is 48 when y is -3 and x is -8. Take note of this statement with the product of x and y. The same process, write the equation that is z varies jointly as the product of x and y. So you just multiply x and y, then that is how you write the equation. Substitute the values, 48 for z, 8 for x, -3 for y. Okay, so you're going now to solve this. 8 times -3 is -24. Divide both sides by -24. You will get -2 as your value of k, or the variation constant. Since you're asked of variation constant and the equation of variation, you now substitute the value of k to the original equation, giving z equals -2xy as your equation of variation. That's it. Next example. If R varies jointly as U and the square of V, and R is -56 when U is -7 and V is equal to 8, find R when U is equal to 3 and V is equal to 15. Please understand the given statement. You now transform that into a mathematical equation. R varies jointly as U and the square of V. Take note of the keyword square of V. So when you translate that, R is equal to K U V squared, because that's the square of V. From there, substitute the values to find K. R is -56, U is -7, V is 8. -7, that 8 squared, that is 8 times 8. Okay. With this, you can divide both sides by -7, 8, 8. Okay. So you can cancel this out because it's just equal to 1. You'll have K. Then from here, this is just 1/8. Or if you want to solve that, you can. Okay. So you have -56 is equal to K times -7, then 8 squared is 64. Then you can multiply -7 and 64, that is -56, is equal to K times -448. From there, you find K by dividing both sides by -448. Okay, -448. Okay, that is just, you can reduce this into its lowest term, that is just equal to 1/8. Okay, that's the value of K. The answer is just the same. Okay, you can have either of the processes. Since you now have the value of K, you will now substitute that K to the original equation to find the equation of variation. Our value of K is 1/8, so to just substitute, that is now your equation of variation is R is equal to 1/8 UV squared. That is how we solve for the equation of variation. Then you now solve for the unknown. Take note that in the question, there are another values of U and V. We'll go back to the problem. If R varies jointly as U and the square of V, and R is -56 when U is -7 and V is equal to 8, there is another problem, which is find R when U is 3 and V is 15. After finding the equation of variation, you now use the values, okay, another values of U and V. U is 3 and V is 15. Just do the same process. You have U3V15. So 15 squared is 225 times 3. That is 675 divided by 8. Therefore, our value of R is 675 over 8 when U is 3 and V is 15. Again, you first use the values, okay, of R, U, and V, negative 56, negative 7, and 8 respectively to find the value of K at the equation of variation. If you now have your equation of variation, you now proceed to the next problem, finding R when U is equal to 3 and V is equal to 15. Our answer is R is equal to 675 over 8. Last example, if T varies jointly with M and P, and T is 40 when M is 2 and P is 5, find T when M is 5 and P is equal to 8. The same process earlier. Okay, so we have here T is equal to KMP. T is 40, M is 2, P is 5. 2 times 5 is 10. Divide both sides by 10. You will have K, which is equal to 4. That's the variation constant. From there, write the equation of variation. T is equal to 4mp. Then the next problem is for you to find T when M is 5 and P is 8. 5 times 8 times 4, that is just 160. And this is now the complete solution. Right? That is for our session. For your individual practice, the volume of a prism with a constant width varies jointly as the length and height. If the volume is 1080 meters cubed, when the length is 24 meters and the height is 5 meters, what is the volume if the length and height are each increased by 3 meters each? Okay, take note, understand the problem. For your answer, please use the comment section. And that ends our session for today. Thank you, Quipper, for the slides used in this presentation. Once again, thank you and happy learning. Don't forget to subscribe and click the notification button to receive updates. This is Sir RP.